BC Chemistry, Unit 4, AOS 2. V for vitamin. We're talking about vitamins, not vendettas. Okay, so first of all, vitamins, their name contains amine in it, but it doesn't really necessarily have to contain the amine group. It was a misunderstanding from early on. So early on, someone realized that there are some of those molecules that are very important, and important means vita. Vita actually means important. They're important to human body. And some of the molecules that they discovered was thought to contain amino functional group. So it was named as vitamins. But later on, we realized actually not all those important small like molecules actually do contain amine. So we take away the E. So it becomes a vitamin. So compared to macronutrients such as protein or carbohydrates or fats, vitamins are micronutrients. It means that they actually just contain, like our body only needs a small amount of them, but they're actually quite important. Okay. So there are substances that generally cannot be synthesized by the body, except for vitamin D, who's actually in the gray area, because not everybody can synthesize vitamin D efficiently. So sometimes we still have to obtain it through diet. Okay. So they are essential for normal growth and development. So they must be a part of the diet. So they exist in small quantity, but they're actually quite important. They're essential for normal growth and development. So vitamins don't share common structure like macronutrients. So like all proteins have common structures, carbohydrates and fats, but vitamins are actually all different. They are instead, therefore, classified as water soluble and fat soluble. So sometimes when it's fat soluble, they need to be carried around the body by carrier proteins. So fat-soluble vitamins, they include vitamin D, A, K, and E. You don't have to memorize it, but when you're presented with a structure, you should be able to tell that it's fat-soluble because they have relatively fewer hydrogen bond-forming functional groups, like hydroxyl groups or carboxylic acid. Carboxyl groups, right? So therefore, if you look at vitamin D, the major part of it is actually nonpolar. So therefore, the entire molecule is relatively nonpolar. So they can form dispersion forces with fat tissue and therefore can be stored in fat. Okay? So because they can be stored in fat, if we take too much of it and it is stored, it might cause hypervitaminosis if there is overdose. So we can actually overdose on vitamin D. So even if we have to take vitamin D tablets sometimes, we have to do it in moderation. So vitamin D is the only vitamin that we actually can synthesize when we are exposed to sunlight. But as I've said, when it comes to this, some people, even if with enough sunshine exposure, they still cannot synthesize vitamin D properly. So we still need to obtain it through diet. Okay. So water-soluble vitamins, so they include vitamin C and vitamin B. Okay, the actual solubility really depends on the number of functional groups that can form hydrogen bond with water. For example, this is a vitamin C molecule, and you notice that they actually, for that molecule, it has a lot of hydrogen bond forming functional groups. So that hydrogen in hydroxyl groups can form hydrogen bond with water easily, right? And the hydrogen on water molecule can also form hydrogen bonding with that oxygen molecule. And all of these oxygen molecules actually. So it's known as ascorbic acid, and it's polar and therefore it's soluble. Okay, so it can be transported in blood. So for all water-soluble vitamins, they all have the common feature that they have a lot of functional groups that can form hydrogen bonding with water, and therefore they can be transported in blood, and of course, they can be removed from body easily through urine, which means that compared to fat-soluble vitamins, we cannot store water-soluble vitamins, and therefore we must keep obtaining them from food. So it must be part of our diet, like regularly. Okay, so all water-soluble vitamins needs to be consumed on a regular basis. Okay, so sometimes if your water-soluble vitamins is cooked in water, so if somehow your vegetables are like cooked in water, we might think that it's healthier, but actually we're actually removing water-soluble vitamins when we're actually boiling them in water. So in that sense, it's not a all cheesy peasy kind of way of cooking, right? The best way probably is eating them raw. Okay. Here is a list of vitamins that we commonly refer to. Some of them are fat soluble, some of them are water soluble. As I've said, you don't really need to memorize which ones are fat soluble, which ones are actually water soluble. You're not required to memorize all the functions of particular vitamins. But what you do need to do is that when you are presented with a molecular structure of a particular vitamin, you should be able to make a judgment to see if they are fat soluble or if they are water soluble.